Hola, estamos aquí entrevistando a Barry Barish, un premio Nobel judío como muchos tantos premios Nobel. Entonces es un placer estar con él. Barry, first of all, thank you for being here in Mexico. It's a real pleasure for us. Could you explain your theory and why you received the Nobel Prize, first of all?
Sure. Um, in 1915, Einstein made a new theory of gravity after we had lived with Newton's theory of gravity for more than 200 years. And that new theory of gravity is very difficult scientifically, but it made a specific prediction, and that is that just like electricity, what we live with, the lights and so forth, have waves, that gravity also has waves. But he didn't think it could ever be detected because the effect is very small. He couldn't envision that in modern days we could make, with modern lasers and optics, much, much more sensitive devices than he could ever envision. And almost exactly 100 years after he made this prediction, we detected waves of gravity coming from the merger of two black holes.
Okay. Could you explain how they move with these two?
I've got these two delicious.
Exactly.
I've got these two delicious candies, and they're like two black holes, or like the Earth and the Sun, and they're going around each other. Now, just as if an airplane, when it slows down, comes down to land, as these lose a little bit of energy to gravitational waves that come off, they slow down a little bit and merge and merge and merge, and then they combine together into one object, making an explosion of gravitational waves that we see.
Okay. It's amazing how you can understand something so far.
And this happened, the one we observed happened 1.3 billion years ago, but so far away in the universe that it took that long for the signal to get to us. By the time it got, and 1.3 billion years ago on Earth, we were just evolving from single cell to multi-cell life. So that's when this thing happened. And then it took a long time to get here because it comes at the speed of light. And by the time it got here, we evolved enough to be intelligent enough to make an instrument that saw them. So that's the story. And then I got this little medal for doing it. So that's the Nobel Prize.
So like they say, everything is connected. So now we discover this phenomenon. How does it affect us? I know that in quantum computers, they think it's going to affect the gravitation, no? Or something else?
When you do absolutely fundamental research to learn about nature, we don't really ask that question, but it has importance. So we don't ask that question because we usually don't have we don't do it motivated to make a better cell phone or make a better something or other. That happens afterwards. So I don't know, other than knowledge, what this will be good for, which is true of most important discoveries. But I can illustrate that on the average, or sometimes, when you learn more, you can use it, sometimes maybe not. In my lifetime, in the laboratories near me, there was a Nobel Prize experiment that saw something called spontaneous emission. That's another concept of Einstein's. And it won a Nobel Prize. This is about 1950, 55. Nobody knew it had any use. It turns out that that's the principle by which lasers work. And lasers are one of the biggest industries we have now, like a $20 billion industry. I knew it only as a physics principle, proved in a lab near me where somebody got famous and won a Nobel Prize. Secondly, near me, I was working for a while at Cornell University, and there was a physicist at Cornell that was in a nuclear physics lab, and he proved a principle, this one's not by Einstein, but another principle of nuclear physics called nuclear magnetic resonance. Nuclear magnetic, you never heard of it?
No.
But well, for a good reason you didn't hear of it, which I'll tell you in a minute, which is that, again, it's a fundamental principle. He won a Nobel Prize. Nobody knew it had any use. But now it is, I think, the most important imaging device we have in medicine. it's called MRI.
Of course.
But of course, they've erased the word nuclear because no one would want to go. Okay, but it's
Okay.
basically nuclear magnetic resonance. So
Exactly.
yeah. So the moral of the story is that some of these learning about nature and how it works sometimes makes huge payoffs, and sometimes it's just knowledge. We do it for knowledge, and we should support it for knowledge. But we have the added benefit that sometimes by learning more about nature, we get very large rewards.
In Spanish, we have a phrase that it's "uno nunca sabe para quién trabaja." You never know. You never know for who are you working. So maybe you're working for the next big technology,
Maybe
and
you don't know it.
you're
You don't
just
know it.
doing
Right,
science
right,
because,
right,
like, not just the studying, but real science. And one day we will use it for everything.
Right.
Did your Jewish upbringing had any influence on what you do and the way you see the universe?
Well, I think, look, all our upbringings influence who we are, how we live, what our values are. I didn't have a religious Jewish upbringing. I wasn't bar mitzvahed, mostly because my family was too poor, so I couldn't go to Hebrew school and so forth. But we lived in a Jewish culture socially, and my wife is Jewish, and I think it's affected my values in life, and I identify with it. And I think that's true of anyone. They grow up in a certain kind of environment, and it's who you are. So it's who I am.
Where are your parents from? Or you?
My grandparents were from the region of Eastern Europe that has changed. Poland used to be much more into where Russia is now. My ancestors grew up in a small a village near Kiev, and came to the United States early in the early 1900s to the United States. They immigrated to Omaha, Nebraska, where I was born, and there was a small Jewish community in Omaha, Nebraska, and that's what I grew up with. And then my family moved to Los Angeles for job reasons and so forth. And of course, there's a much larger Jewish community in California. And so I grew, as I say, I'm not religiously Jewish, but I had a Jewish culture and friends, wife, and so forth my whole life. And so it defines me.
How did you get interested in physics?
That's a long story, but to make it short, as a kid, I loved to read. That's the first. My parents did not go to college. They had. My father's father died when he was very young, and he had to work, and so he didn't. I don't think even finish high school. My mother came from a family where her father didn't permit the daughters to go to college, so she didn't go to college. So I didn't have parents who were educated. They had a value in education, but they weren't educated. As a kid, the first thing I discovered that made me educated, if you want, was reading. And then I discovered fiction, reading stories, and I love storytelling. From the time I was young, I would make up stories, I read stories, and I love storytelling. So as a young, and then eventually, maybe at the age of 12 or 13, I discovered reading fiction that was better than, say, mystery stories or science fiction, real literature. And I loved it. And I loved storytelling, I loved writing, I loved reading. So clearly, I was destined to grow up not to do science, but to write the great novel. So that's what if you asked me at 15, I was going to write the great novel. That was my ambition in life. But my talent was really always in science and mathematics. I was very good at it, but I didn't understand that to do anything with it. I actually got dissuaded or turned off of doing literature, I hate to say this, by a high school teacher. And this is she not purposely. She probably loved what she.
Well, happily for the world.
She maybe she loved what she did, but she gave us a novel to read that shouldn't be given to this 15-year-old because I didn't understand enough about the world to appreciate it. It's a great novel, but not for a 15-year-old, and it's a very long novel. It's Moby Dick, and so I don't know if you've ever read Moby Dick. It's a great novel, but it's very metaphorical. Well, this 15-year-old didn't understand metaphors very well, and it's a battle between a whale and a sailor. And there's a long chapter, it's at least 100 pages long, from the whale's point of view. And reading it when I was 40 or so, I understand that. Reading it when I was young, it was the most boring read about this white whale and what he was thinking and what he looked like and blah, blah, blah. And so I thought, if this is great literature, I'll do something else with my life. And I did.
Thank you very much.